Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen or selected from the same book, Elements of Electromagnetics by Matthew N.O. Sadiq. Okay, dear students, actually in this video we are going to solve three problems, while in this book these three problems are just a part of a problem or example or exercise, okay, but because that is to say that book's problem has three parts, A, B, C, and this is only the A part, but the problem is so comprehensive that it can be split in three separate parts. So I have done so. I have split part A of that problem in three separate problems. Okay. As usual, we first come to statement. Convert point P having coordinates 1, 3, 5 from Cartesian to cylindrical and spherical coordinates. Okay, this Cartesian or rectangular components point has to be converted into a point having cylindrical and spherical coordinates. This is a comprehensive problem. That is why I have split that problem in three separate problems. Okay, dear students, before going to its solution in a formal or regular manner, we first go through a few snapshots which will provide us a foundation regarding the solution of this problem. Okay, so first snapshot is about circular cylindrical coordinates rho, phi, z. Okay, rho has formula rho is equal to x square plus y square under root y, while phi is equal to tangent inverse y over x and z is equal to z. Okay, that is to say in cylindrical coordinates third coordinate does not change. Okay, in Cartesian or rectangular components and in cylindrical coordinates third coordinate, that is z, is the same. Okay, moreover, next snapshot says x equal to rho cos phi, y equal to rho sin phi, z equal to z. Okay, dear students, actually this conversion is being used where we have to convert rectangular or Cartesian into in which we have to convert cylindrical or spherical into Cartesian or rectangular. Okay, next snapshot says that spherical coordinates r, theta, phi are determined according to the formula r is equal to x square plus y square plus z square whole under root, while theta is equal to tangent inverse x square plus y square under root divided by z, and phi is equal to tangent inverse y over x. X is equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Okay, previous snapshot was about conversion from cylindrical to rectangular or Cartesian coordinates, while this conversion is for transforming spherical coordinates into Cartesian or rectangular coordinates. Okay, dear students, next snapshot is about Greek alphabets. Purpose of this snapshot is just to ensure that Greek alphabet involved in this problem is being pronounced properly or not. Here, dear students, this symbol phi has been used. Okay, phi similar symbol is psi. Okay, we should differentiate between phi and psi. Okay, in this problem phi has been used. Okay, next, dear students, a part of a table. This table has been chosen from the book of Douglas C. Gyan Kohli. Okay, this is the beginning part of that table. Actually, this table is lengthy, but we have just chosen concerned parts. Okay, this is beginning part of that table, while next is the concerned portions. Okay, actually this table starts from 0 angle to 90 angle. Okay, and in the end inverse tangent is found. Okay, dear students, actually this table goes from 0 degree to 90 degree, and basically these measurements relate to both coordinates in the first quadrant. Okay, dear students, actually a circle is divided in 4 quadrants. First quadrant is from angle 0 to 90. In this quadrant, both x and y components are positive. Next second quadrant is from angle 90 to 180, and in this quadrant x is negative while y is positive. The third quadrant is from 180 degree to 270 degree, and in this quadrant both x and y are negative, while in the fourth quadrant, that is from 270 to 0 degree, x is positive and y negative. Okay, so dear students, this thing we also have to keep in mind. Okay, because this table deals with only 0 to 90 degree, but accordingly we have to subtract that value from pi, or perhaps sometime even add that value in pi. Okay, so these are the concerned portion of that table. Okay, now we are going to start our solution in a formal manner, regular manner. Okay, given x equal to 1, y equal to 3, z equal to 5, rho becomes equal to x square plus y square, and hence rho becomes equal to 3.16. Okay, first quadrant has been found. Now we move forward. Given x equal to 1, y equal to 3, z equal to 3, this implies that phi is equal to tangent inverse y over x is equal to tangent inverse 3 by 2, 3 by 1, and this is equal to tangent 3, and this is equal to 72 degree. Dear students, this here both are y and x are positive, so exact 72. We go back for a while and see from where we have taken this 72 degree. Okay, yes, we are going back. 72 degrees, 72 degrees, 72 degrees, 72 degree, 70. Yes, this is 72, this is 71, and this is 72. 71 degree is 2.904, while 72 is 3.078. Okay, it means 72 is the closest value. Okay, that is why tangent inverse has been taken as 72 degree, because here both x and y are positive and first quadrant is relevant, and we do not need to make any adjustment in that value. Okay, I think it is okay. Okay, 72 degree. Now dear students, in previous part we had found rho, in this part we have found phi, and third coordinate is already same, so rho phi z is becomes equal to 3.16, 72 degree and 5. Okay, now we we are going towards the spherical coordinates. Okay, given x equal to 1, y equal to 3, z equal to 5, then this implies that r becomes equal to x square plus y square plus z square. This becomes equal to 5.92. Okay, next, x is equal to 1, y equal to 3, z equal to 5. This implies that theta equal to tangent inverse x square plus y square over z. This becomes equal to tangent inverse 10 under root over 5. This becomes equal to tangent inverse 0.6324, and this becomes equal to 32.5 degree. Here once again, dear students, upper and lower all are positive, so we have not to make any adjustment. Okay, we see that 32 degree where falls 32 degree 32 degree 32 degree yes, this is 32 degree. Okay, dear students, we see that 31 degree value is 0.601, while 32 degree becomes 0.625, while our required value is in between these two values, so we have taken 31.5, perhaps 31.5 or 32. We see, let us see. Yes, 32.5. 32.5. Actually, this value, that is 0.63, falls in between 32 and 33 degree. So we have taken in between. That is, we have taken 32.5 degree. Okay, this implies that r theta 5 becomes equal to 5.92, 32.5 degree and 72 degree. Okay, dear students, now second part. Which actually next problem we have converted that one part of the book into 3 separate problems. Okay, convert point t 0 minus 4 3 from Cartesian to cylindrical and spherical coordinates. Solution: given x equal to x y z, so rho is equal to this, rho becomes equal to 16 under root becomes equal to 4. Okay, given so phi becomes equal to tangent inverse y over x is equal to tangent inverse minus 4 over 0. Here, dear students, 0 is not, division by 0 is not allowed. It means it becomes infinity, and hence this value either becomes equal to tangent 90. Okay, dear students, this situation, that is tangent infinity. In this case, tangent 90 is equal to infinity, but here we are not going to take 90 degree because one value is minus. Okay, so we have to add pi in 90. Okay, 90 plus 180 equal to 270. Okay, here y is minus, x is 0. Due to this minus condition, we have actually tangent inverse infinity is equal to 90 degree, but here we have taken it as not 90 degree but 270 degree because y is minus, so we have added 180 in this 90. Okay, so rho phi z equal to 4, 270 degree and 3. Then given x y z, so r is equal to x plus x square plus y square plus z square under 2. This becomes r becomes equal to 25 under root becomes equal to 5. Next, given x y z, so theta equal to tangent inverse x square plus y square over z. Theta tangent inverse 4 by 3. This equal tangent inverse 1.3, and tangent this here angle is taken as 53.5 degree. Okay, here once again all are positive, x and y. Okay, all numerator and denominator both are plus, So we do not need to make any alternate, we do not need to make any adjustment or addition subtraction. So exact value, actually this value, that is 1.33, is such is of such nature that it falls in between 53 and 54. That is why we have taken this value as 53.5. If we take this value from internet online converter, then its exact value can be found, but I have used here manual calculation as per table. Okay, so r theta 5 becomes equal to 53.5 degree to 70 degree. Next, third part, third problem, convert the point S minus 3 minus 4 minus 10 from Cartesian to cylindrical and spherical coordinates. Here, dear students, given x, y, z equal to so, okay, then rho becomes equal to x square plus y square, to x becomes equal to 25 under root 5 becomes 5, okay. Then next part, given so phi equal to tangent inverse y over x equal tangent inverse 1.33 equal to 233.5. Okay, dear students, here x and y both are negative. Both are negative. It means third quadrant is applicable, and hence we have made substitution. Okay, when we see this value 1.33, its value is about 53 degree, but we have to add 180 degree in this 53 degree, so it has finally become 233.5. okay, because these both are minus, so this situation falls in third quadrant where x and y both coordinates are negative. Okay, hence this answer. Next, given x equal to x, y, z equal to so, and r equal to so, and r is equal to 11.18. okay. Next, given x, y, z so, then theta equal to so, and hence theta becomes equal to tangent inverse 0.5. This becomes equal to 153.5 degree. Okay, dear students, this is the end. This implies that r, theta, phi, all the three coordinates become finally equal to 11.18, 153.5 degree, and 233.5 degree. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.